Hello student, this is Darasa Online. My name is Eddie Gepshana. I'm teaching advanced mathematics. This is part of presentation with the topic of differentiation. In differentiation, we are going to see how to find the derivative of a function from the first principle. The first step, we are going to derive the general formula of find derivative of a function from first principle, and later on we are going to continue with the review question. Join with me till the end of this lesson. So dear student, here consider the sketch of curve. This curve is f of x, is called the f of x. So we are going to see how to find the slope of this curve. So for the case of horizontal, that is, we have change in x, that is from A to B. But again, for the vertical change, of course, here we have change in y, that is from B to C. So in this case, you can define a slope. So we say slope, this is given by vertical change, that is vertical change over horizontal change. Which is the same as change in y over change in x. So in this case, of course, it's the same as delta y over delta x. That is how to find the slope. But in this case, we are going to consider a limit, that there will be a limit. And of course, the slope will be represented by f dash, that is derivative of our function. And if you consider that there is a limit, this will be the limit of, as change in x approaches to 0, we are going to have, now, for the case of delta y, that is change in y, it will be the same as f of x plus change in x minus f of x. So that is the same as f of x plus change in x minus f of x. For the case of horizontal change, that is delta x, we are going to have x plus delta x minus x. So in this case, this will be over x plus change in x minus x. So in this case, x minus x, now this one will be 0. So in this case, we have f of x dash is equal to limit of, as change in x approaches to 0, we have f of x plus change in x minus f of x, then over change in x. But for the case of simplicity, I will let change in x is the same as h, or is equal to h. So for the case of simplicity, that is, for simplicity, we say let change in x is equal to h. So in this case, we have f of x dash is equal to limit of, as h approaches to 0, then we have f of x plus h minus f of x over h. So that one is our general formula of find derivative of a function from first principle. So this is the formula that we are going to use to find the derivative of a function from first principle. Now it is time to do the review questions. The review question that we are going to use our formula. So, my dear student, this is our first review question. That is, find the derivative of f of x is equal to 2x plus 7 using the first principles of differentiation. So, you remember our general formula, that is, find the derivative of a function from first principle is given by f of x dash is equal to the limit of, as h approaches to 0, we have f of x plus h minus f of x over h. So that is our general formula. So in this case, f of x, we have f of x, this is equal to 2x plus 7. But again, for the case of f of x plus h, this one is equal to 2x plus h, then plus 7. So just substitute in our formula. So in this case, we have f of x dash is equal to the limit of, as h approaches to 0. Then for the case of f of x plus h, this is the same as 2x plus h, then plus 7. Then minus, then we have f of x. So f of x is our function, that is 2x plus 7. So this one over h. So we just open up the bracket as follows. So this will be the limit of, as h approaches to 0. So we have 2x plus 2h plus 7 minus. So in this case, we are going to have negative 2x minus 7. So this one divided by h. So here we have 2x minus 2x. So this one will be 0. And we have 7 minus 7. Again, this one is equal to 0. So we are going to remain with, that is, f of x dash is equal to limit of, as h approaches to 0. So here we have, that is 2h. We have 2h, then over h. So this one is over h. So again, h over h. So this one is equal to 1. So my dear student, here we have the answer, that is, so f of x dash is equal to 2. That is for the case of linear function like this. Let us proceed with the second review question. That is question 2. So, my dear student, you have the second review question. This time we have a quadratic function. That is, differentiate f of x is equal to 5x squared minus 3x by first principle. So you remember our starting point. That is the general formula. That is f of x dash is equal to the limit of, as h approaches to 0, then we have f of x plus h minus f of x, this one over h. So in this case, f of x is our function. So here we have f of x, which is equal to 5x squared minus 3x. Then the next is f of x plus h. So that is, for the case of f of x plus h, this is equal to, so wherever there is x, we just add h. That is a small increment in the value of x. So here we have 5 bracket of x plus h squared minus 3x plus h. Now we have f of x and the f of x plus h. So in this case, my dear student, we have f of x dash will be equals to the limit of, as h approaches to 0, now we have f of x plus h, which is the same as 5 bracket of x plus h bracket squared, then minus 3 bracket of x plus h. So my dear student, here we just expand as follows. So we have the limit of, as h approaches to 0, we have 5, then bracket of, that will be x squared plus 2xh plus h squared. Then minus, so here we have 3 bracket of x plus h, then minus again bracket 5x squared minus 3x. So this one over h. Now it is time to open up the brackets. That is the limit of, as h approaches to 0, we are going to have 5x squared plus, we have 5 times 2xh, that is 10xh, then plus 5h squared. So again here we have negative 3 times x, that is minus 3x, then again 3 times times h, that is minus 3h. So followed by minus 5x squared, but this time we have a negative times a negative 3x, that is plus 3x. So this one over h. So my dear student, in this case we have 5x squared minus 5x squared. So this one will be 0. But again we have negative 3x plus 3x. Again this one is equal to 0. What will remain here? We are going to remain with the limit of, as h approaches to 0, we have 10xh plus 5h squared minus 3h. So this one over h. So in each term, we are going to divide by h. So on dividing by h, we have 10xh over h. So this one is equal to the limit of, as h approaches to 0, we have 10x. Then we have 5h squared over h, that is plus 5h. Then again, negative 3h over h. Here we are going to have minus 3. So as h approaches to 0, this one will be equals to 10x plus 5 times 0 minus 3. So in this case, we have 10x minus 3. Therefore, f of x dash is equal to 10x minus 3. That was the case for the quadratic function. So, my dear student, we proceed with review question number 3. So here we have a question that is question 3. That is so my dear student, that is our question. By first principles, differentiate f of x is equal to square root of x. This time our function is a square root of a variable. So remember our general formula, that is f of x dash is equal to limit of, as h approaches to 0, we have f of x plus h minus f of x over h. So in that case, f of x, that is given, f of x is equal to radical x or square root of x. And f of x plus h, this is equal to square root of x plus h. So in this case, we have f of x dash is equal to the limit of, as h approaches to 0, we have the square root of x plus h minus the square root of x over h. So at that point, we are going to rationalize the numerator. So here we say rationalize the numerator. So to find the rationalizing factor. So the rationalizing factor will be as follows. That is f of x dash is equal to limit of, as h approaches to 0, we have the square root of x plus h minus the square root of x over h. So here we times by the rationalizing factor, which is the square root of x plus h plus the square root of x over the square root of x plus h plus the square root of x. So that is our rationalizing factor. So you remember the concept of difference of two squares. So when we have a minus b and a plus b, this one is equal to a squared minus b squared. That is the concept of difference of two squares. So here we have f of x dash is equal to the limit of, as h approaches to 0. So here we have the square root of x plus h. This one is squared minus the square root of x squared over. So for the case of denominator, we have h times the square root of x plus h, then plus the square root of x. So here we are going to have the limit of, as h approaches to 0, we have x plus h, this one minus x over. So here we have h bracket of the square root of x plus h, then plus the square root of x. So in this case, when we open up the bracket here, we are going to remain with the h. So my dear student, here we have, that is f of x dash will be equals to the limit of, as h approaches to 0. So here we remain with h, that is h over h times the square root of x plus h plus the square root of x. So again, we can simplify, that is h over h, that is 1. So we have the limit of, as h approaches to 0, we have 1 over the square root of x plus h plus the square root of x. Now, as h approaches to 0, we are going to have, that is 1 over the square root of x plus 0. So again, plus the square root of x. So in this case, we say the f of x dash is equal to 1 over 2 the square root of x. That is how to find the derivative from first principle when you have the variable under the root. So that is our review question number 4. And this time we have the reciprocal of square root of x. So remember, f of x dash is given by the limit of h approaches to 0. We have f of x plus h minus f of x, this one over h. That is our general formula. So f of x is our function given in the question, which is equal to 1 over the square root of x. For the case of f of x plus h, this is equal to 1 over square root of x plus h. Therefore, f of x dash will be equal to the limit of, as h approaches to 0, we have 1 over the square root of x plus h, then minus 1 over the square root of x. Now this one divided by h. So here we are going to find the LCM. So the LCM, that is f of x dash, is the limit of h approaches to 0. So the LCM will be the square root of x plus h, then times the square root of x. So in this case, our LCM divided by the square root of x plus h, we are going to have the square root of x. So here it will be the square root of x. Then minus, we have our LCM, that is the square root of x plus h, times the square root of x divided by the square root of x. So we are going to have the square root of x plus h. But this one divided by, that's divided by h. So again, this is the same as the limit of h approaches to 0. We have the square root of x minus the square root of x plus h over. So this one will be h bracket of the square root of x plus h, then times the square root of x. So we need to rationalize the numerator. So here we say rationalize the numerator. So we are going to have the limit of, as h approaches to 0, we have the square root of x minus the square root of x plus h over, that is h, then we have the square root of x plus h, then the square root of x, times, now our rationalizing factor will be the square root of x plus the square root of x plus h over the square root of x plus the square root of x plus h. So again, we have to recall the constant of difference of two squares. That is a minus b, again a plus b. This is equal to a squared minus b squared. That is the concept of difference of two squares. So in this case, we have the following. That is, f of x dash is equal to the limit of, as h approaches to 0, we have, that is, the square root of x squared minus the square root of x plus h squared over. So here we have, that is, h times the square root of x plus h times the square root of x. But again, this one times the square root of x plus the square root of x plus h. So, my dear student, here we have the limit of, as h approaches to 0, square root of x squared. This one is the same as x minus, that is, the square root of x plus h squared. That will be minus x plus h. Then over h bracket of the square root of x plus h times square root of x, then again square root of x plus the square root of x plus h. So this one is the same as the limit of, as h approaches to 0, we have x minus x plus h. So here we remain with the negative h over, we have h square root of x plus h square root of x square root of x plus the square root of x plus h. So at this point we can simplify, that is, negative h over h, we are going to have negative 1. So in this case, we have f of x dash will be equals to the limit of, as h approaches to 0, we have negative 1 over, we have the square root of x plus h, then square root of x bracket of square root of x plus the square root of x plus h. Now in that point, remember, h approaches to 0. So here we have negative 1 over square root of x plus 0 times square root of x bracket of square root of x plus square root of x plus 0. So x plus 0, that is x. So we have negative 1 over, so we have square root of x times square root of x, that is x. Then we have square root of x plus square root of x, that is twice square root of x. Therefore, f of x dash is equal to negative 1 over 2x, then square root of x. That is how to find the derivative of a reciprocal of a square root of a variable by first principle. Let us proceed with the last review question. So, student, we have the question that is by first principles differentiate f of x is equal to x cubic plus x squared plus x plus 1. So again, remember our general formula, that is f of x dash is equal to the limit of, as h approaches to 0, we have f of x plus h, then minus f of x over h. So in this case, we have the function that is f of x. So f of x is given by x cubic plus x squared plus x plus 1. While f of h, x plus h, that is f of x plus h, is equal to x plus h cubic. That is, wherever there is x, we add h. That is a small increment in x. So again, plus, we have x squared, that is x plus h squared. Then again, plus x, that is x plus h. Then plus 1. So we substitute in our formula as follows. So we have f of x dash is equal to limit of, as h approaches to 0. So we start with f of x plus h, which is x plus h cubic plus x plus h squared plus x plus h, then plus 1. Now this one minus our function, which is x cubic plus x squared plus x plus 1. So this one over, that is over h. So it's just a matter of expanding what we have here. So this is the same as the limit of, as h approaches to 0. Now for the case of cubic, that will be x squared plus 2xh plus h squared, this one times x plus h, then again plus, for the case of x plus h squared, again that one is x squared plus 2xh plus h squared, then plus x plus h plus 1, then minus, we have x cubic plus x squared plus x plus 1, but the whole thing over, that is over h. So again here we have the limit of h approaches to 0. So in this case here we are going to have x cubic plus 3x squared h, again plus 3x h squared, then plus h cubic. That is for the case of this product. So this one plus, then we have x squared plus 2xh plus h squared, again plus x plus h plus 1 minus. So now we open up the brackets here. We are going to have minus x cubic minus x squared minus x squared, then minus x minus 1. Again, the whole thing over h. So x cubic and x cubic, that one is equal to 0. But again, we have x squared and x squared, that one is equal to 0. And we have x minus x, that is 0. And the 1 minus 1 again, that one is equal to 0. So here we remain with the limit of, as h approaches to 0, we have 3 x squared h plus 3 x h squared plus h cubic plus 2 xh plus h squared plus h, then over h. Now it is time to divide by h in each term. So on dividing by h, we have the following result. That is f of x dash is equal to the limit of, as h approaches to 0. So we have 3x squared h divided by h. So we have 3x squared. And again we have 3xh squared divided by h. That is plus 3xh. Followed by h cubic divided by h. We have h squared. Then we have 2xh divided by h. We have 2x. We have h squared over h. That is plus h. And h over h, again, that is 1. But remember, as h approaches to 0, here we are going to have 3x squared plus 3x times 0, then plus 0 squared plus 2x plus 0, then plus 1. So in this case, we have 3x squared, then plus 2x plus 1. That is the derivative of our function. So here we say, therefore, f of x dash for our function is equal to 3x squared plus 2x, then plus 1. So, my dear student, it is time for assignment. So, my dear student, here is the assignment for you. Find the derivative of the following using first principles of differentiation. Number 1, we have f of x is equal to square root of x minus 7. And the second one is f of x is equal to 1 over square root of 2x plus 5. Number 3, we have f of x is equal to x squared plus 4x plus 4. And number 4, we have f of x is equal to e power x. And the last assignment question is f of x is equal to x power n. My dear student, I hope you enjoyed this lesson of advanced mathematics, where we are discussing on how to find the derivative by first principle. Make sure that you are not missing another lesson of advanced mathematics. Till next time, have a good time. Bye.